Should I try the microphone? I'm trying the mic. Can you hear me? Just checking. You can't hear. Okay, sorry. Can you come up, please? So my name is still Michael, and everybody calls me Mike. And this session is about networking in System Center Virtual Machine Manager, and it's also about storage. And there's multiple reasons why we do this. One of the reasons is that every time I do training and classes in this, all the attendees we have in the class go like, yeah, I do understand that. And then you explain everything, and they go like, I have no idea what you're talking about. And then you need to re-explain the same thing every morning for an entire week. And when we leave the class in Friday afternoon, there's always one that says, do you mind just, briefly repeat everything again? Because that would... And I'm feeling stupid. I'm supposed to know this stuff. I'm the teacher. And I come to the conclusion that it's not really my fault. It's, of course, Microsoft's fault. And the reason is very simple. There's really a hard time figuring out what kind of settings you actually are applying. Is this something we have, or am I building it? Is this something I'm creating, or does it already exist? So it's a mix of what you have and what you're about to create. That's one of the problems. The other problem is that it feels like it was never really meant for being a UI. This is more of a bunch of developers that figuring out how to do this in PowerShell. And after a while, someone said, do we have a UI for this? No, we don't. Oh, shoo. Bob, can you create one? Fast. We need one, because everybody doesn't know how to do everything directly with the APIs in PowerShell. So there's a lot of explaining here. Now the third part of this is another, and that is even if you create everything perfectly good, you do it by the book, and it still doesn't work, it's not you. You're doing it correctly, but there's a third party involved. Someone did actually create a driver that didn't work. Someone had a setting in the driver that didn't work. So a lot of times, it's always about disabling every cool feature there is, and then it works. What? Shouldn't the feature work? Yes, of course it should work. Anybody know any developer that doesn't do anything wrong?
No. Microsoft?
I can't repeat that. But it's true. I mean, it's whenever you have something really new and it hasn't been tested, it's a new feature, it's rarely going to work. So usually, last week I had a good example. I was actually putting up an NVGRE network with an NVGRE router for a customer, and everything works except UDP. TCP and ICMP works perfectly fine. UDP doesn't. It took a while to figure that out because we can ping everything. I just couldn't get the DNS name resolution because the UDP traffic doesn't flow. Well, there's a feature in the Broadcom network adapter called encapsulated offload task, blah, blah, whatever. And it's very simple. Find every network you have in the entire network, turn it off, and UDP works. And then you Google for it, and you realize that there's about 1.2 million other people that have the same problem. But you can't find anything on their homepage about it. It's just that everybody else have that. So that is also very common. But there's a couple of things we need to know before we start. Oh, I already covered that. Networking. In System Center Virtual Machine Manager, networking is kind of difficult. We have the physical network, that's fine. And then we have the Hyper-V switches. And if you think of switches, you actually have two switches in your environment. You have the physical switches, and you have the virtual switches. So here's a question for you. Which one of these does matter? The physical or the virtual? Which one is the important switch? The virtual switch. Because the physical switch is just a cable extender. Oh, well, we need to have a Cisco switch. No, you don't. Because if you build this correctly, you actually never log on to the switch because you don't need to. It doesn't do anything except forwarding packages. Quality of services, VLANing, every network component is inside a virtual switch. So we do run big data center with crappy switches, like NetGear switches. I wouldn't say they're crappy, but you get the point. It's just a switch. It delivers 10 gigabit Ethernet and nothing else. We have customer that never configures the switch. They can't log on to it because it doesn't do anything because it's not configured at all. And if they are configured, they are all configured the same way. So you can change and replace any switch with any switch. Because the real configuration is in the virtual switch. That's where it matters, right? The next network is the logical network, and the logical network is the definition of how the network is actually created. On top of that, we have VM networks. So why do they have that? Can't we just have one? Well, there's a layer here. We have the fabric layer, which is the layer you can see and you can touch and you can play with. And then we have the virtual layer, the workload layer, where the user actually, or it's not a user, but the guy that builds the VM or whatever, he can see the network, but he can never see the physical network. I don't want them to see my network. Have you been to a hotel? Anybody been to a hotel? Would you like to, I mean, you go to a conference trip, right? Would you like to share the hotel room with a working colleague? Or would you like to have your own hotel room? I passed 50. That means I don't want to wake up and see some other human body that is not my wife in the morning. Trust me. This is the same thing. You want to separate a fabric network from the virtual machine network. That's why they have a logical network and a VM network, and on top of that, we run all the VM networks. Now, there's a couple of words we need to know and to do understand before we even start. This is a bunch of words. RSS, RDMA, VMQ, LBFO, and they do really mean things. They are actually very important. Let's grab the first one. Let's start with, I can't remember what order I put the slides. Well, let's do the RSS first. The RSS is a very nice feature. If you do gigabit network, it doesn't matter. If you do anything else than gigabit, which means more than gigabit, then RSS is extremely important. So why is that? I turn it off because if I have it enabled, it doesn't work. And now it works, but it's really slow. Strange. RSS is the only way in Windows to distribute the network between the CPU cores. If you don't have RSS working, everything is going to bypass one core, and the performance of that core is going to be the limitation. That means you can gain about 2.5 up to 3 gigabit of performance on a 10 gigabit network. How fun is that? I have this really cool 10 gigabit network. Yes, and it performs like 2.5. Yes. Have you disabled RSS? What's that? Well, most likely it's disabled either intentionally or unintentionally. So RSS needs to be working to be able to distribute the load between all the networks. Well, there's another way to do that, and that is inside virtual machines. RSS is working outside the virtual machines, and VMQ is working inside the virtual machines. Well, RSS is actually working inside too. Virtual machine queues is a way for the hypervisor to distribute the network load from the virtual machines between virtual machine queues, which is in the network adapter itself. It's actually, it's a port. It's a port switch. Think of the network adapter as a switch, because when we install Hyper-V on it and we create the switch, we are shifting a network adapter into being a switch. And a virtual machine queue is actually a switch port. So does it matter what kind of network adapter you have? Yes, it does. Please. Just because the vendor says this network adapter supports VMQ, it doesn't mean it's a great adapter. Let me give you an example. For each virtual machine network adapter, you need one VMQ. That way, it has a physical port to react with. Otherwise, it's going to do memory copy for each frame. So this network adapter has 2 VMQs at the same time. How many virtual machine network adapters can you have with high performance if you have 2 VMQs? Oh, here's a simple calculation, 2. So I had a customer who says, we have about 300 VMs per server, and VMQ doesn't work. Well, turn it off. Well, if you turn it off, we're going to get bad performance. Well, you're running an MLX network adapter, aren't you? Yes, it supports 2 queues. So the other 298 machines have never been using that anyway, so it doesn't matter. If you go to another network adapter, like an Intel network adapter, it has 256 queues. The price tag of these 2 network adapters is the same. It's just that one of them was created for virtual load, and the other one was created for something else. I have no idea what they created it for. But obviously, it's not meant for being virtualized. So it really does matter to check the specification, and you need to have VMQ running if you have a lot of VMs, and they need to have network performance. Otherwise, they're going to run every network traffic through CPU 0, which is then going to be overloaded because it runs another couple of tasks as well. That's teaming. LBFO is teaming. It's just that that's the name Microsoft have. Load balancing and failover. That's creating a team. And we need to team. Yeah, if we're not teaming, here's the problem. Let's assume that you have a host running with 8 network adapters. And the old traditional way of doing this is very simple. That network adapter is for a virtual machine that runs on that VLAN. That network adapter is for iSCSI. That network adapter is each and every network adapter has its own purpose. How do you load balance between? Well, you can't, because you have dedicated NICs for dedicated purposes. So that means that you're going to have this really cool 10 gigabit network adapter for live migration. How often do you do live migration? Once a month. Okay. So here's a really good network adapter that is used once a month. The other one is constantly being used, and it's pounding on 10 gigabit. The other one is taking a rest. It's like having 4 employees, and you're all responsible for, I don't know, for marketing. And you are responsible for typing the A letter, and you're responsible for the B letter, and you're responsible for the C letter. Oh, lucky you, we didn't use any A letters this week, so you're on leave. You don't need to do anything. Nobody would ever try to do something like that, or maybe. But that's what happens when you have dedicated network adapters. That's why you team. You throw them into one giant team, and then you divide it virtualized. The fourth thing is the RDMA, or SMB Direct. The problem with that is that it's vendor specific. It's like Microsoft supports RDMA. That's cool. So what does it mean? Well, we support direct memory access. We support SMB3 Direct. Oh, that's cool, SMB Direct. That's cool. But the problem is that you need to pick and choose. Currently, there are 4 technologies, or 3 major, but one of them is divided. You can either do RDMA over converged Ethernet, also called RoCE. RoCE has 2 versions, RoCE 1 and RoCE 2. Has nothing to do with the Boxer. It's just that the US guy always says, oh, you use RoCE V1. Like, what? Is that a movie? No, it's not a movie. The V2, which is a newer version, is routable. The V1 is not routable. The purpose of using RDMA is to get latency down. Everybody talks about IOPS. Yes, IOPS is important, but what's actually more important is to have a low latency. We need to have very low latency. Otherwise, it doesn't matter how many IOPS we have, because having 50,000 IOPS at a latency of 14 milliseconds is ugly slow. It's really, we get a lot of IOPS. It just takes forever. Okay, so. Problem with converged Ethernet is that you need to have a network adapter that supports it, the switch needs to support it, and you need to configure DCB. DCB is not easy to configure. The other option is to do InfiniBand. InfiniBand doesn't need DCB to be configured. InfiniBand is really cool because they run in 40 and 56 gigabit Ethernet and go like, oh, but a Cisco 10 gigabit switch is so expensive. How expensive could an InfiniBand switch be? about half the price or tenth of it. Oh, so it's cheaper? Yes, pretty much. It's actually really cheap. It's just that they have very strange connectors and very strange cables. So it's InfiniBand stuff. You can't use it for anything else. But it's Ethernet, and it's routable, and they have a latency that is less than 100 nanoseconds. Instead of milliseconds, we talk about nanoseconds. That's nice. And the third option is actually to use iWarp. iWarp is approximately the same thing as Rocky. It's just that they use Ethernet frames, so they are always routable, but they have a higher latency. And I haven't seen many customers using that. The two currently most common used technologies today is either Rocky or they use InfiniBand. And you need to buy this stuff from start. So let's say that I'm going to do InfiniBand. Well, that depends on the vendor of your hardware. How do you mean? Well, Dell is working with the following vendors, and the following vendors create the following network. So you can't really mix and pick and choose here, depending on its HP. I asked HP, do you have any Rockies? Yes, we do. Okay, so what kind of switches do you have? We have one. Okay, so you have one switch that supports ROC. Yes. And that is a blade switch? Yes, it's a blade switch. Okay. How many network adapters do you have that supports that? None. Okay, but you do have network adapters that you can put in on a rack. Yes, but you don't have any rack switches for no. So okay. I'm just wondering who is working on marketing there, because they are obviously missing something here. Dell is better. They have a broader selection of this. And the reason why it is that this way is because they were never really prepared. None of the vendors were really prepared for software-defined networking, storage, and compute, because they built everything in the hardware. And now everybody's going away from that. That means it takes a while for the vendors to catch up, to create new things like that. So you really need to do these considerations. If you do 10 gigabit Ethernet, you don't really need to have this. The benefit is very small. But if you want to do 40 or 56, then you really need to have it. Otherwise, it's not going to work. There's a lot of different ways to build this. This is pictures I've stolen from a TechNet blog somewhere, but they are really good. So this is one scenario. We're using something called non-converged networking, meaning that we manually build everything. We can build some of these in Virtual Machine Manager, but the other things we need to manually build. We have one team for management. It's using a LACP trunk together with the dynamic team. That needs to be manually configured both in the switch as well as on the server, so it's kind of... The other one is it's a team with 10 gigabit Ethernet adapters, and we use them for cluster shared volumes and for live migration together with the SMB multi-channel. That kind of works. And then we have another team that we use for the virtual machines. Now that team, the last one to the right, is also running the virtual switch, because there's a problem with here. To get really good performance, I need RSS, right? I need to divide the traffic. To get really good performance in the virtual machines, I need VMQ. You can't have them both at the same time in the same switch. It's either or, currently. So this gives you good performance. It's easy to build. It's monstrous to manage, because you have so many network adapters and all of them needs to be manually configured. So this works in your lab or in the backyard or something like that, but it's not for large scale. It doesn't really work. This is another one. I like this because this is easy. You only have 2 network adapters, right? Bang, here's 2 network adapters. And you build everything on top of them. This is perfect when you want to build a stack with Hyper-V compute machines, and they only have like 2 network adapters in them. And you want to build a massive amount of them. easy to deploy, easy to configure. They have one team, one switch. On top of the switch, we build all the virtual network adapters, but they don't have RSS. That means that performance from SMB3 is going to be pretty bad. They're going to sideload one of the CPUs, so CPU 0 is going to be highly overloaded. But this works when the load is light. So maybe this is like two 56 gig machines, a 128 gigs machine, and you want to run a bunch of web servers or something like that. That's going to work. It's easy to build, it's easy to deploy, it's easy to manage. Oh, God. Here's another one. In this case, it's someone that actually bought something called blades and blade chassis. And you can see beneath we have the physical network adapters, the LUMs that we have. And you start to specify, I want to create 4 network adapters or 3 network adapters of the physical ones. Whatever you do, this is close to be the worst I ever seen. It's a nightmare because you have quality of services in 2 locations and they can't talk with each other. You have one quality of service system in the physical layer and you have another in the virtual layer. And you can't align them. There's no way to communicate between them. You just need to figure out something that statically kind of works. This is ugly. This is slightly better, but not much. In this case, we use dynamic quality of service weights in the physical layer, and then we have the same story on top. But they can't really communicate with each other, so you still have the same problem. It's just, from a worse perspective, this is less worse. Now, this is something people should be killed for. It's when you start to putting the fiber channel over Ethernet in the same way, in the same network stack, and you try to run this. It's just, don't do this. It doesn't work. Fiber channel over Ethernet is able to kill SMB traffic, vice versa. Network traffic management, everything can kill each other. You're going to end up with, I can't ping. No, you can't do anything because it's dead. It doesn't work. Do you think I've seen this? For customers that says, well, we have a problem. No shit, Sherlock, you have a problem. I can see you have a problem. And you start measuring around this, and it's like, it's don't do this. When you do have blade chassis and you have all these things, this is the closest one we have to this is okay, right? But it's not perfect, but it's okay. We have, in this case, one team for management, cluster shared volumes, live migration, SMB, and all that stuff. And then we have another team for all the VM traffic. This way we can have VM queue on that second team, and we can have RSS running on the first team. And that's going to give us both high performance and reasonable virtual machine queue management so we can divide the traffic. It's all about having the traffic, the network traffic, being divided by all your cores. That's why you need many cores, not high-performance processors, but many cores to make this work. We have been building all these different things for about 4 years in different shapes and to try them out. I have redesigned my own personal lab at least 20 or 30 times just to figure out that this was a bad idea, and this was another bad idea, and this was even worse. This is okay. Another problem we can see is this. Every server you buy is sold by someone that really likes the environment. Therefore, they are put in something called dynamic power saving. If you buy something really expensive like a Ferrari, would you like to change the engine to a 40 horsepower engine to save the environment? Some of you might do that. I wouldn't do that. I would like to keep my 850 horsepower engine in that car because that's the purpose of the car, to drive really fast. The default setting in every server you buy is to save the environment. The problem is that you can't control that from inside Windows unless you modify the setting. You need to either switch it into OS controlled mode or to high performance. We prefer to have it in OS controlled mode because then I can control everything within the operating system itself. But default, it's power saving. So how much do you think you will benefit from doing this? Well, I had a customer calling me last week because I told him to shift it, and he increased the network performance by 50%. And that's nothing, right? Like 50%. Anybody want to increase the network performance with 50%? No. It's just a push button, and of course you don't want to do that. You need to restart the server. That's a bad thing. So when you deploy the servers, you should have some kind of script that configures the server correctly from the beginning. Figuring this out 6 months later is not even close to be fun. So let's check how that looks like. It says waiting. I hate this. There you go. And no, this is not a demo environment. This is the live production environment. It's a customer in Stockholm. I usually use their... No, it's not a customer. Even I have limits. But it would be cool, right? Doing a demo on a live production system, and you go like, oh, the TV channels just went down. Yeah, I know, sorry. You can see it there. That's the default setting for every machine that you buy. Anybody seen this before? Have you changed it?
Oh, yes.
Did you get better performance?
I've never tried running.
You never tried the other one, okay. So the only downside of this is that it's gonna, the fan is usually revving up a bit. It's getting cooler actually, but it's more noisy. Buy ear protection. Well, it sounds a lot when I have the servers at home. Okay, they were never designed for being home, even if I do have people running it at home. So you shift it to OS control. I prefer OS control, but I do have a customer that says, no, we're going to do static high performance. It really doesn't matter. It's just that OS control means you can control it in Windows using PowerShell and other things like that, which is kind of nice. Strongly recommend to do that. Okay, so let's start building this. We're going to cover the networking stuff. I'm going to build it in two ways. We're going to start building it in our demo environment, and then we're going to look in the real production environment how it actually looks like. So here we have, that doesn't make sense. But I can do this. I can't do that. Sorry?
Connect again, and then use full screen.
Yeah, I saw that. You're right. Here. I can connect like that. So here it is. In the virtual machine manager, everything that has to do with network is in the network section. You select fabric and you go to network. And the first thing you need to start doing is building your logical networks. The logical network is the representation of what you have. You need a bunch of them. You're not going to have one. Why? Well, you need a logical network for live migration, cluster shared volumes, maybe backup, management, everything that you need in your environment. And one thing that a lot of people are missing is when they start using SMB. SMB networking is very nice. It's just a file share, so it's really cool. How many would you like to have a clustered file share? Anyone? Highly available? You would like to have that? That's a smart choice. When you do that, it doesn't work unless you create a multiple of networks. If you have one server with many network adapters in one network, it's automatically going to use multi-channel. When you have a cluster, that doesn't work. You need to create multiple networks. So we usually create SMB1, SMB2, SMB3, SMB4, which is just separate IP nets, has nothing to do with VLANs. It's just IP subnets, because that's how multi-channel actually works. So we need a bunch of networks. And all of them are going to look the same way. We're going to use one connected network. We don't need any kind of virtualization. This is a management network. But we can create a VM network immediately because we're going to be able to put our virtual machines on top of this network at the same time. So we give it a name. It's going to be called Fabric. Fabric SMB1. Next. And then you specify the host group. You specify the VLAN. I'm going to run it on the blank VLAN, meaning no VLAN at all. 192.168.2.0/0. Next. /24. Next. And then you do view script. And when you do view script, you do a copy, and then you open PowerShell, and then you do a paste, and then you type in all the other networks that you're going to create. You need to document it as well, right? Last week, I was attending a customer, and they needed some help, so I asked for the documentation. They gave me this massive amount of documentation. It was a screenshot of every click they ever done. Why do you have this? Well, to be able to, recreate disaster recovery. So when everything blows up, you expect someone to sit here and try to figure out what they actually did? Yeah, that's like, ancient Egypt, and you try to decipher all these paintings on the walls. Disaster recovery is stored in a PowerShell script. That can be run by anyone. Oh, well, not my CEO, but not my kids either. So you create all these networks, and then you configure the networks, because you need to have an IP pool on them. Or would you like to use DHCP in your Fabric environment? Yeah, let the server decide. It's like going back to the 60s, the hippie culture. Let them flow around. Pick any IP, not an issue. Doesn't work. It works for workload, for like file servers and stuff that you run on top of this, but it doesn't work for the Fabric. It really needs to have static IP addresses, according to me, not according to Microsoft. Fabric, SMB1 IP pool, and then you specify this. And I usually never start on one, and I usually leave a couple of IP addresses in the top. Next. I don't need a gateway. This is just a separate subnet for SMB1 traffic. I don't need DNS. I don't need any of those. I just need to have the capability of saying this network adapter should have a static IP address from this subnet. Doesn't need to communicate with anything else than the same subnet. And you keep on repeating this until you created every network that you need to have. Therefore, you need to have a design before you start. How many networks do I need to have? Should I have 2 SMB networks, or 3, or 4? Should we have iSCSI? Blah, 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 blah. You need a whiteboard and a pen. And that takes approximately a day to figure out before you even start. When that is done, next step, we need to have something called port profiles. And you're going to create port profiles. And port profiles is the settings for how the team should work. The switch is the switch, but this is the setting inside the switch. So you need to create one. It's called a uplink port profile, and we're going to call it uplink port profile for everything. And then you can define the load balancing algorithm. It says host default. That means if you're running a server 2012 R2, it's going to be dynamic. That's the choice you would like to have. And the other one is the teaming mode. Now, this is switch independent. That's what I do recommend. Switch independent means that my instructions to the techie is put the network cable in a hole where it fits. Because it doesn't matter where they put it. It's going to work anyway. If you have a LACP trunk, the trunk needs to be configured, and that cable needs to go to that, things like that. And when we have this, the disaster, it's like, oh, should cable A4 be in switch B, port 42, or should it just plug it in? Most providers I work with prefer to have it this way. They accept the fact that, yes, we are going to lose some performance, but it's going to be so much more redundant and much more flexible. Next. And then you add all the networks that is supposed to be in this configuration. This is just so you don't need to define all the network on every host. You put all the networks in this profile. And since we're not going to run any NVGRE or anything like that, we don't need to enable network virtualization. And really, this only applies to Windows Server 2012 anyway, because in R2, that is always enabled. It's just that nobody really reads the text anymore. It's just, but it says in here, actually. Okay. So now we have the logical network, and we have the port profile. Now we can create the switch. They added this text in VMM 2012 R2. Before this, it says next and nothing else. They added this because it's obvious. This is not really super simple. So when we had a chat with Microsoft, they said, this is hard for people to understand. You need to clarify it better. Check. That's what they did. It's called dswitch. If you do need to use what's called SRIO, you need to enable that from the beginning. I strongly recommend you to not use SRIO unless you actually know what it is. It's a really high-performance network feature. But it should only be used when you actually need to have that. Well, I always need to have that, yes, but you're also going to lose some of the virtualization capabilities because now you're actually mapping the physical network adapter into the virtual machine. So that means that the entire idea of virtualization is gone. But it's really fast. So it happens, but not very often. We need to add the extensions, and that's going to be default, so that's fine. And then we switch into team, and then we add the uplink port profile for everything. I always create a team. Even if I only have one network adapter, I still create a team. Why? Because then I can cheat. Here's a customer running on something, and they want to change the network adapters. So what we do is very simple. Turn off the machine, you add the 2 other network adapters, and then you open the team, add them, remove the old ones, and everything is up and running. It's a way to be able to change network adapters without recreating switches or anything like that. So that's pretty neat. So I do it even for one network adapter. And then we add the virtual ports, and people ask me, what's this? This is very simple. This is quality of services. All these profiles have predefined settings like minimum bandwidth width and maximum bandwidth weight and features and functions, and they are predefined. So host management, that's what you have for your hosts, right? So they can communicate with each other. And then you have medium and you have low. And for instance, if Johan wants a VM machine, I need to make sure that I have this port classification, low bandwidth. So he gets really annoyed and complain. And then I say, it's all about money. And then he pays me, and then I can change it into high. Or he harassed me, and then I change it to high anyway. So you add everything that you need to have, right? And this is just classifications and nothing else. Okay, so then we're good to go. We have the switch, we have the team, and maybe you want to have a dedicated switch for just management, because you have like the 2 1 gigabit network adapters, and even if you're not going to put any VMs on them, you can just create a team and a switch with just the management, and you never put any VMs on it, but then you can create it using VMM. And then you have the other team and the other switch for other purposes. We usually come up with about 3 switches. 1 for management only, 1 for everything, and 1 for NVGRE gateways, because they contain a very strange configuration. I'm going to show you that later on. Now, when that is done, you can then build that by going into the server itself. I'm going to remove that and create a new logical switch. I'm going to pick the switch, and then I can pick all the network adapters I have. So this is how it's going to team those network adapters, create the switch. Whatever you do, do not press OK now. That is a very certain way to cut every kind of connectivity you ever have with that machine, because you're going to create the switch, but you're not going to have a virtual network adapter. You need to add that. So we're going to add one called the Fabric Management Network Adapter. That's the way I'm going to communicate with the machine. And then I have my network here, so I'm going to add that network, and I'm going to classify it as host management. There's a small checkbox that says this virtual network adapter inherits the setting from the physical management. That means basically this. It's going to steal the MAC address from the first physical network adapter you had in this list. Whatever IP address that network adapter had, whatever DHCP setting it had, whatever IP address settings that network adapter had, whatever MAC address it had, that's going to be inherited into the virtual network adapter. And that's going to give you an error in this server event log. The server event log is going to say this: you have a duplicate MAC address in this machine, which is true, because the physical network adapter still has the old MAC address, and the virtual network adapter has it at the same time. I can't tell you how many times I've seen customer trying to fix this, which is pointless. This is an error that the VMM team and the Hyper-V team has been fighting for, to get the Windows team to remove that message. Because when you run virtualized, that's how it works. Yeah, but we can't remove that error message. But it is not an error. Well, we can't remove that error message. It's like talking to a brick wall, obviously. So there's a lot of articles on that. Duplicate MAC addresses. Don't fix it. It's not a problem because you don't have a protocol bind to that physical network adapter. You have a virtual switch protocol, so it doesn't communicate on the network anyway, that way. And then you add all the networks, the other networks. So let's create the other one, like the SMB one. And I connect that to SMB1. And in this case, I specify the classification of, well, low bandwidth is a bad choice. SMB network should be high, maybe. So I should have added that. But then I can say, well, pick an IP address from that IP pool. And the static MAC address is going to be 000, which means it's going to create a new MAC address. That's going to be a static IP address. So this is how we do. We built it this way. In reality, this is how it looks. That is the wrong machine. Here's the right machine. Fabric. Logical networks. This is all the logical networks we have. Some of them is used for VLAN traffic because they are bound to old systems. Some of them don't have an IP address because that's DHCP managed. But you can see we have all the cloud network for different things here with MAC addresses. All these networks are then injected into our port profiles. And you can see we have them here. An uplink port profile, an uplink port profile only for management, and we have a gateway uplink for the NVGRE network. And on top of that, we have the logical switches. And we only have 3. And most customers will actually be sufficient with only having 1 or 2. We have 3 because we use all the features that is available to use. If I go into this uplink switch, you can see it has the same extension. It has only one uplink port profile, which is a team. But we also added all the different classifications, so we can have different classifications for every machine that we have. So my recommendation here is, number 1, you need to start thinking of how the network actually should look like. How many networks do I need to have? Should it be VLANs? Should it just be IP subnets? How's the design looking? When you have that on a piece of paper, then you take the piece of paper and you build the same thing in here. You can't build this on the fly. It's like building a car on the fly. Let's add a steering wheel somewhere. Maybe it fits over here. No, it didn't fit here. I'll cut it loose and mount it over here. Well, it didn't fit over there. I wouldn't drive that car. Scary. So, even if you do everything like this fully correctly, you're going to have things like this. When you then deploy these machines to the network, and you've done it by the book. Here's the switch, here's the team, here's everything. Great, everything is working. No, it's not. Let's see if I go to, isn't that a server? Yes, here's the server. Here we have. Yes. No, I need the other ones. I need the logs. Oh, sure, I need to open it here. Event viewer. Yes. Available processor sets of the underlying physical NICs belonging to the LFBO team, blah, 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 blah. And it ends with the processor sets overlap when LBFO is configured with a sum queue mode. That is actually an issue. As long as you have that, you're really running everything with RSS and VMQ and everything is cool, right? It's just that you defined that the base processor for all network adapters should be 0. So everything is still running on one proc. And you can see that in the performance. If you pick up the CPU, it's going to see that they have no load whatsoever, except the first one, which is spiking on 100%. How do you fix this? Can you do that in VMM? No, you can't. PowerShell. And if you search for that error, you're going to find at least 40 or 50 blogs that says, well, this is how you do it. If you have 24 CPUs and you're using hyper-threading and you have 2 procs, that means that the first 12 is on that, the other 12 is on that, and that means that every even number is a real proc and every odd number is a hyper-threaded one. So then you take all the VMQs you have and you say, this network adapter should use the following processors, and this network adapter should use the following processors. We asked Microsoft about this and said, why didn't you put it in the logic from the beginning? Yeah, I know. You should have done that. You're right. Yeah, we should have. But you didn't do that, no. So why didn't you do that? Time. We didn't have time. Hopefully this is going to be fixed in vNext. So far it's not. This is actually something you really need to fix. And it's just PowerShell. So Google for that, because you're going to have that problem. You don't have it on a laptop because you only have one procs, right? So that's not a problem. It's when you have multiple procs and multiple network adapters, which you have it in production environment. So that happens all the time. Storage. Well, storage is kind of cool and kind of simple too. Shouldn't do that. You either use scale-out file servers or you use direct attached storage. So what we consider to be the best practices in all these scenarios is always to use the scale-out file server. Well, not really. 6 months ago, I did a customer job, and they had 3 host machines. And I asked them, how many VMs are you going to run? 10 to 15. Okay, we're not going to do scale-out file servers. We're going to do SAS Direct. But you told me that's not the best practice. No, but it's going to be too expensive. Just plug it in, it's going to work anyway. But in some kind of real environment, scale-out file service is considered to be very smart. So even if the customer use iSCSI, SAS cabling, or they use fiber channel, or they use storage spaces, you put everything behind scale-out file servers. I'm going to give you a fast glimpse of why. Because immediately you don't need that. It's after a while you're going to realize that building without scale-out file servers was the dumbest thing I ever did. So here's a customer. They have a 3-node cluster, and they build it the traditional way, meaning 3 servers and some kind of storage connected to all these servers. And on the front side, everything is connected to some kind of network. And everything is working perfectly fine. Now, here's the problem. You need more storage. So you either expand the SAN, which is going to be fine, or you add another node. If you add another node, well, that means that you also need to get a new HBA, of course. And you need to connect the HBA to the existing SAN, which means that you need to find a SAN manager, which is a very strange individual. They usually have long hair and look strange and smell a bit. So, not all of them, but in general. You need to modify the SAN, but you also need to modify the cluster. You need to modify a lot of moving parts. Adding a node to a cluster that is 3 years or 2 years old is always scary, because you're modifying something that actually works. Okay, but that's fine. Well, is it really fine? Let's say that we really need to buy new stuff. Oh, let's buy new stuff. Okay, so let's buy a new set of Hyper-V hosts here, like these 4, and connect them to the same network, which is fine. And then we buy another storage solution, and we connect the storage solution this way. It actually could be the same storage solution. It's just that the storage is connected on the other side. Now we need to move the VMs from the old cluster to the new cluster. We can't use them, move them through the SAN, so we need to move them over the network. Oh, that's marvelous. We're going to move 48 terabyte over a 10 gigabit Ethernet. That's lovely. We're going to kill the network for the next 6 months while we're moving this stuff. Yes, I know. Which is horrible. So instead of doing that, we have the storage, we have the scale-out file servers, we have the 3-node cluster, and we connect it to, that was a 4-node, sorry. And we connect it through the network, like this. And yes, it's dual connected and all that stuff. If I need to get new storage, I get new storage connected to the network, and then I can move the VMs, but I can just move the storage part. They can still run on the same hosts. Or you can add more hosts by more or less buying a new stack like this and connect it to the same network. And moving all these machines, we talk about, say you have 1,000 VMs. Moving 1,000 VMs from this cluster to this cluster when the storage is the same, we talk about an hour. I just evicted the old cluster in less than 1 hour instead of 6 months. Now, 6 months is nothing, right? I mean, who cares? Moving around the same data from the same location over the network down to the same location also feels really great. You're moving 48 terabytes from that location over the network back to the same location? Yes. How smart is that? Don't do that. So scale-out file server becomes smarter. The only problem we have with scale-out file servers, and I'm going to disable that, is that they need to be configured. These are production servers, so I can't really do whatever I like with them. Well, I can, but then I don't need to hurry back home anymore because my CEO is going to be mad at me. This is very easy. This is one of the storage nodes. If I go into the device manager, I have hard drives, many. All of these are storage spaces, except for this one. That's actually an iSCSI target behind. So we have both SAS, JBODs, using storage spaces. At the same time, we're using an old MSI 2000 G3 as storage for reference image and other. It's not really the fastest solution ever. I don't think fast is anywhere in the production specification on that, Sam. Not sure. So these are just created. And there's different ways to create that. One is to use the storage pool, and you create a storage pool, and you go in and say storage pool, and then you specify all the hard drives you have. I can't see anyone right now, so because we already used them up. The interesting part when you do storage spaces is that all the UI tools you have are more or less incorrect. They cannot really be used unless you're doing a test. To gain performance, you need to spread read and write. That makes sense, right? That is called columns. When people do this in the UI is limiting itself to 8 columns. You can't do more in the UI. The UI is trying to be friendly. So the UI is meant for 3-year-old people that really create storage spaces. And you're older than that. So you need to figure this out on your own. If I go back to the cluster here, sorry, I can go here. you can see that this is running with a mirror and have five columns. That means that I have 10 disks in parallel when we write to this. I'm writing to 5, but I'm reading from 10. That's how you gain performance. This one, it's a two-way mirror with 12 columns. That means I read from 24 disks in parallel, and I write to 12 of them. That gives me better IOPS. That gives me much better performance and transfer, but it also means that every time I need to extend this, I need to buy 24 more drives, since the columns is based on 12 times 2. I can only add 24 drives at a time if I want to extend this. The biggest problem we have here is networking. If I go to networks, you can see that in this case we only have 2 networks, the SMB 204 and the SMB 205. And the only way to accomplish that is to have multiple network adapters in the host servers, and at the same time give them different IP subnets so that the clients, the host in this case, can connect to them. That is one of the biggest problems we have. So with that said, thank you for stopping by. I want to stay around for the evening, and I want to be here for the next 30 minutes for answering questions. Thank you for coming